Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called, this is SVS 432, and this is Richard's sort of he's just keeping track of all the puzzles he's done. That's actually quite a few. 432 is quite a bit. And he does essentially variants of Sudoku that he finds interesting, which is, pretty cool. Today's variant is pointing arrows. And let's get to the rules. We have apply classic Sudoku rules, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box here. We have every circle contains the sum of all digits on the adjoining arrow. So this is typical arrow Sudoku here. So this is equal to the sum of the digits on the arrow. So for example, if this were say 2, 2, and 4, this would have to be an 8 to add up to the digits of the sum of the digits on the arrow. In addition, the digit in the circle appears also at least once in the direction of the arrow. That means whatever digit is here, in this case an 8, has to appear in the direction of the arrow. So an 8 would have to be here, if that were the case. So 8 could be here, or an 8 could be here. And obviously not in both cases, because then that would break normal Sudoku rules. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this is the sum of 3 unique digits with another digit. 3 unique digits at minimum adds up to 6. So this is 1, 2, or 3 at most. This has to be 7, 8, or 9. And these digits add up to 8 at most. So it's 1 through 5 here. Hmm. Interesting. For these digits add up to a minimum of 3. So this digit can only be 6 at most to add up to 9 at most here, right? Because these two digits, again, add up to 3 at least. So this is 1 through 6. Similarly, this is also 1 through 6. But the point is that this digit here, we're going to mark it as blue, must be somewhere along this diagonal where the arrow is pointing to. Can't be here because this is, first of all, it sees that, so couldn't be there anyway. So the blue has to be one of these two. This is also possibly 1 through 6. This is also possibly 1 through 6, and this could be 1 through 7 here, technically. These digits at least add up to 3, but if this were 1 and 2... Okay, so this is interesting. The central box is very interesting. These 3 digits add up to, at most, 1 single digit, but it must be 1, 2, and 3 at minimum, so this is 6 through 9. This could be 1 through 6, and we don't know anything about these. So this digit is different, and it must be one of those two. So we're going to mark that as dark, as medium gray. It's one of those two. We don't know which. This one, okay, so this cell here obviously must be one of these two. Cannot be this one because that would be the same. It would be in the same row, and we'd have a repeat. So therefore, it must be here. This one cannot be either of these, so it must be one of these two. Okay. Ah, this cannot add up to 6. If this adds up to 6, this has to be a 4. This would be 1, 2, 3. This would be at minimum 4 and 5, which is already 9, and 9 plus another digit would be greater than another digit. So this has to be at least 1, 2, 4. So it's 7. This can't be 3. Therefore, this can't be 7. This is 8 or 9. It could be 1, 2, 4 here, and this is 3, 5. And then this is 1. So that is possible. These digits must add up to 7. It has to have a high digit of 7. This is 1. This could be 1 through 6 again. So this pink has to be here. Okay, since this pink is here, this cannot be the same digit as this. If it were... Right. Then this pink would not have a digit that matches it in the direction of the arrow, which breaks this rule, this pointing arrows rule. So since this is pink, this is blue, these add up to, at minimum, 15, right? 5 unique digits must add up to 1, 2, 3, 4, 5 at minimum. That's 15. That means this is 6 and 1 and 1 at minimum. That adds up to 17. But that's the maximum 2 unique digits can ever add up to. So this must be 1 here, and this must be 1 here. This has to be an 8-9 pair, but where is the blue in the central box? It's not the same as the pink, because the pink has to be here. So it cannot be any of these. It can't be along its own arrow. It can't be here, because we know this can't be 8 or 9. So it must be here, which forces this to be 8 and this to be 1. This has to be 9. So the blue has to be 8 and the pink has to be 9 here. Therefore, this adds up to 1, 2, and 4 here. This is a 1, 2, 4 triplet, which eliminates 1 here because of the 1s in the rows. So this has to be a 1 here. This has to be a 3, 5 pair, adding up to 9 with a 1. So in box 5, this has to be a 6, 7 pair. This can't be 6. We have a 9 here, a 9 here. So a 9 has to be one of these 2 digits here because it points that way. The 9 is there. This blue means 8 has to be one of these 2. We're not sure which. Okay. So we have 9 going there. 8 going one of these 2. 9 has to be one of these 2. So this can't be 9 or 8. This is 7 at most. It could be down to 4 possibly. Oh no, this is 2 and 3 at minimum. So this has to be, this is at minimum 2 and 3. So this is 1 or 2 here. To add up to 7 at most. So it could be 6, it could be 7. This could be 2 and 4 then. We know there's a 2 here guaranteed. So this cannot be this. Okay, this can't be 2, 4. It has to be 2, 3 pair. So this is 2 and 3 to add up to 6 or 7 because it can't be 8 and it can't be 9. So this can't be 2. This is 4, which means this can't be 4, so that's 2. This 2, 3 pair eliminates 3 here, so it's 5 and 3 here. That means this is a 6, 7, 9 as possibilities. This is 1 or 2, with the 2 or 3 adding up to 6 or 7. This can't be 1. It can't be 3, 4. 8, or we don't know what this is. Okay, so this cannot be 8 or 9. It's 7 at most. It could be, you have 3 minimum here, 1 minute. Okay, this can't be 1. So this is at least 5. 5, 6, 7. It cannot be 8 or 9 because of the 8 or 9 in the column and the box. So this can't be, this is at minimum. Okay, it can't be 1. This is at minimum 2 and 3. So 2, 3, and 2, which would be the minimum here, forces this to be a 7. Because that's the maximum value we can have here, and that equals the minimum for this. So this must be 2 and 3. This can't be 3. This must be 2, which makes this 3. This cannot be 2. Well, the rest of column 5 has to be 5, 6, or 8. And this is 5 or 6, which means this is 8 or 9, because it cannot add up to 5 or 6 would be either adding up with 1 and 2 or 1 and 3 to add up to 8 or 9. So this cannot be 4, 5, or 6. This can't be 1. We definitely need a 1 on this arrow. You can't have 2 and 3 with 5 because that adds up to 10. So this has to be 1, which makes this a 2, which makes this 7. That means this can't be the orange. So this has to be 7 here. So the oranges match. That means, okay, this can't be 7 here. So 7 has to be one of these two. Okay, so that matches that. This is 2. The rest of box 8 must be a 3, 4 pair. And this can't be 3 because of the 3 in the column. So this is 4, this is 3. The rest of column 4 is a 5, 6 pair. And the rest of column 6 is a 4, 9 pair. So 9 cannot be here, therefore this can't be 6 adding together. This can't be 2 or 3. This can't be 1 or 2. We know there's a 1 guaranteed to add up to 6, 7, or 8, right? To add up to 6, it'd be 1, 2, and 3. If it's 7, it adds up to 1, 2, 4. If it's 8, it could be 1, 2, 5 or 1, 3, 4. But it requires a 1 no matter what. So 1 has to be here. So this 7 point means that 7 has to be one of those two. This 8 means 8 has to be one of those two. This 9 means 9 has to be here. 7 means 7 has to be here. Okay. We don't have any information here. This cannot be 7, 8, or 9. 8 has to be here to fulfill this pointing arrow clue. And 7 or 9 are already in the column. So this is at most 6. It could be 5, 4, or 3, but it can't be 3 or 4 because of the 3, 4 pair in the row. We have a 5, 6, 5, 6 pair in row 8, which eliminates 5 and 6 in the rest of the row. That leaves the remaining digits as 1, 2, 7, 8, and 9. 9 can never be on an arrow. This can't be 7 or 8 because it must be add up to 5 or 6. So this is 1 or 2 here. 8 has to be one of these two. That's fine. 1 and 2 cannot be here because of the 1, 2 in the column. This is 1 or 2. To add up to 5, it would be 1, 4, or 2, 3. To add up to 6, it would be 1, 5, or 2, 4. So this is 3, 4, 5. This, however, cannot be... Okay, so we have a 2, 3... Okay, we have a 1 in column 7. So this can't be 1. We have a 2, 3 pair in column 7 also, which eliminates 2 and 3 in the rest of the column. This can't be 2. This can't be 3 then. So this is 4 or 5 guaranteed. This is 1 or 2. Interesting. If this were 6 and this was 1, 2, and 3, the problem is this would be 3, which would force this to be 2, and this then couldn't be 1, 2, and 3. So this can't be 6. It's 7 or 8. If it's 7, this is 4. This would be 1 and 2. That's possible. Rest of column 7 must be 4 through 9. 9 cannot be either of these. This can't be 8. 4 through 9. 9 cannot be here. Where is the 9 then in column 7? 9 can't be here because of the 9 in the box. 9 can't be here because of the 9 in the row. This can't be 9 because of arrows. This can't be 9 because of arrows. This can't be 9 because of arrows. Therefore, this must be 9. So this must be 8 here. That means this is 1, 2, and 5 adding up to 8. This can't be 2. This is 1. This adds up to 6 because it can't be 5 here. So this is 6. 1 can't be here. 9 can't be here. We have a 2, 7, 8 triplet in box 7. This is 1 and 5 adding up to 6. So this can't be 5 here. This can't be 5 or 8. So this is 6, which makes that 8. That means 5 cannot be here, here, or here. This can't be the 1. So this has to be 1 here. This 2 eliminates 2 here. So this is 3. This is 2. That eliminates 2 here. Therefore, this is at minimum 1, 3, and 4, which means this has to be 8 because that's the maximum. So this is 8. This can't be 8. This can't be 8. These can't be 4 because of a 3, 4 pair in the box. The 6, 7 pair eliminates 6 and 7 in the rest of the column. So this is 4. 8 has to be one of these two to make this pointing arrow work. So an 8 has to be one of these 3 digits, so it can't be here. So this is 8, which means these can't be 8 here. Where's the 2 in box 3? It can't be here, so this must be 2 here. So we have pointing arrow 7 is here. 7 is here. Where is the 7 in column 3 then? It cannot, this 7 eliminates 7 here, so this is 6, this is 7. In column 3, 7 has to be here. Because it can't be here because of the 7 in the row. Can't be here because one of these must be a 7 because of the pointing rule. Can't be here because of the 2, 7 pair in the box. So it must be here. So this is 7. This has to be a 5 because that's the only remaining digit left in box 3. What is this? I'm not sure yet. Okay. We have a 9 pointing that way. We have a 7 pointing that way. We have an 8 pointing here. That works. 8 pointing this way. So 8 has to be one of these 2 digits here. I'm not sure which. 6 must be along this diagonal. So 6 has to be one of these 2 digits here. 7 is already here, so that's satisfied. 9 is here, that's satisfied. 9 is here, that's satisfied. 8 is done that way. Rest of column 8 has to be 6, 7, or 9, right? And 7 cannot be here, so this must be a 6, 9 pair. It can't be 9 here because of the 9 in the row. So this is 6, this is 9, that has to be 7. That leaves in box 6 a 5, 8 pair. That leaves in box 9 a 3, 4 pair. Okay. In row 7, the remaining digits are 1, 3, 4, 6. 1, 3, 4, and 6. And this can't be 1. Can 7 ever be here? If 7 were here, it can only be with 1 here to add up to 8. But 8 is not possible in that box. So this can never be 7. This has to be 2, which makes this 7. So this can't be 7. That forces 7 in box 4 to be there. 2 and 1 add up to 3. That works. 2 and 3 add up to 5. That works. 2 and 4 add up to 6. That does not work. 2 and 6 add up to 8, which does not work. So this is 1 or 3, and this is 3 or 5. That means if this is either 1, 2 adding up to 3, or 2, 3 adding up to 5. Well, first of all, 5 can never appear on this diagonal, so this can't be 5. Then this must be 3, which makes this 1. This can't be 1. This 3 eliminates 3 here, so this is 4, this is 3. These can't be 3. This becomes a 4, 6 pair. 3 has to be along this diagonal 4 point, the pointing arrow, so this is a 3, which makes this a 4. Okay. So we should have all the arrows done, essentially, right? 7 points to that 7. 8 points to this 8. This 8 points to this 8. 9 points to that 9. This 9 points to one of these two digits being a 9. This 7 points to that 7. This 8 points to one of these being an 8. This points to a 6 being one of those two. And the 3 points to the 3. The remaining digits in row 9 are what? 5 and 9. This 7 eliminates 7 here, so this is 6, this is 7. Actually, we already had that. Remaining digits in row 5 are 4, 5, and 8, but 8 cannot be here. Remaining digits in row 4 are 2, 3, 5, or 8, and 8 cannot be either of these cells. This can't be 2. Okay. Where is the 3 in column 3? Can't be here because of the 3 in the box. Can't be here because of the 3 in the row. And this can't be 3 because of the 3 in the row. So this must be a 3 here, which means these can't be 3. This 2 eliminates 2 here. Where's the 2 in box 4? It can only be here. So this is 2. Okay. Where is the 6 in column 3? Oh, this can't be 6 because of the 6 in the column, so this forces this to be a 6 because of the arrow rule, pointing arrow rule. This 6 eliminates 6 here, so this is 9, which makes that 6. This 6 eliminates 6 here, so it's 4 and 6 here. That leaves this as a 4, 5, or 9 in column 3. We have 4, 5, and 8 in the rest of column 2. This can't be 8. 4, 5, and 8. This 6 eliminates 6 here, so this is 5, which makes this 6. That means neither of these can be a 5. We have a 4, 9, 4, 9 pair in row 1, which eliminates 4 and 9 in the rest of the row. This can't be 4, so this is 8. That means this can't be 8. We have a 4, 5 pair here, which eliminates 4 and 5 in the rest of the box. So this is 8. This is 5. This is 8. That leaves this as a 1. We have a 4, 9 pair here, but it can't be 4 because of the 4 in the column. So this is 9, which makes this 4, which makes that 9, which makes that 4. That 4 eliminates 4 here, so this is 5, 4, 5. This can't be 5. This is 9, this is 5, and this must be a 3. And that's how you solve it. Fairly straightforward, right? Interesting use of the pointing arrows. There's actually seems like there could be potential there. I particularly like this, actually, the break-in, where basically this couldn't be 9, so the 9 had to be here. But we didn't know it was a 9. But we did know that these had to be different digits, though, because this digit had to be the same as that digit. This digit couldn't be any of these digits, therefore it had to be here. So that was an interesting break-in there. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.